Hello, this is Naz Babar from NB Lessons. Today my topic is going to be dissecting Ethernet frame. In my last lecture, what I talked about was how the Ethernet frame gets from point A, in this case laptop 1 to laptop 2. If you have not heard my lecture, please go back and listen to it. Then this lecture will make more sense to you. But I'll go ahead and do a real quick overview or recap. So in my last lecture, what I said was that we are basically sending data from laptop 1 to laptop 2. And this is basically an Ethernet network. In between is a router. And then we have an Ethernet network right here. So basically in this case, as you recall, data was stuffed into IP packet, and then IP packet was stuffed into frame, Ethernet frame. And then it was put on the wire, Ethernet wire as a frame. This frame has a source MAC address of A, and a destination address, it should be B, which is the MAC address of laptop 2, but it doesn't have that. But it does have default gateway MAC address, which is the IP address, this right here, which is the MAC address is C. So when it frame comes to switch 1 examines it and says, okay, the destination is this MAC address, so it sends it over here. Router basically looks at the frame and then looks at the IP packet inside and looks at the destination IP, which is 100.10.1.1, and then it basically creates a new frame with a new new destination MAC address, which is BB, and puts it on a new frame. This is basically a new frame, puts it on wire, switch 2 gets it, switch 2 looks at it, and it says it has basically destination MAC address of BB, and switch 2 knows because it has the MAC address table in there. It sends it to laptop number 2. Laptop number 2 receives the frame. It basically de-encapsulates, takes the IP packet out, and then takes the data out and presents it to user, and we are done. After that, this frame and this IP packet are discarded. Now let's look and see, take a look from the top and see what the heck is in Ethernet frame. So that's what we're going to do. So this is a frame, okay? And this frame basically has a destination MAC 6 bytes, source MAC 6 bytes, type 2 bytes, and this is the data from the IP packet. Remember, Word file was being sent. This is where it's located. And this right here is FCS. This is basically means frame check sequence. Now let's get into details of what these, each section has. So before a frame is sent, it has a preamble. Preamble is basically 64 bits mixture of zeros and ones, but always ends with 1. Okay? The purpose of preamble is to let the destination know, hey, expect a frame from me. I'm about to send you a frame. So like I said, preamble is a 64 bits. It lets the receiver knows that the frame is coming, and also lets the receiver know from where the frame is coming. It's not really a part of the Ethernet frame, but I just wanted to mention that because it does happen before the actual frame is put on the wire. Destination MAC address, pretty clear. In this particular case, it's going to be BB, which is the MAC address of laptop number 2. Source MAC address is 6 bytes, which is pretty clear. It's going to be AA, which is the MAC address of laptop 1. Type 2 bytes. Type field is 2 bytes. So basically in this type byte, you have things like IP version, is it IPv4, IPv6? It does not go above on the higher layers like application presentation layers. It just basically kind of like, tells you what kind of version it is and so forth. okay? Now this is the important field, that's where we have data, okay? So the limit on this data is 46 to 1500 bytes. If you recall, when I was talking about one of my lectures on IP packet, I told you that the routers have by default a 1500 bytes MTU size, maximum transmission unit size. So that's why we have upper limit up to 1500. Minimum is 46, all right? So what happens if a sender is sending an IP packet which is less than 46 bytes? What happens? What happens is that the NIC card on laptop 1 will add some zeros to make it 46 bytes, and that action is called padding. So keep that in mind. That's an exam question. So in the end, we have FCS, which means frame check sequence. What does frame check sequence do? Basically, it uses something called CRC, which is cyclic redundancy check, okay? So basically what it does is that when the packet is sent, okay, this uses a mathematical algorithm. The laptop 1 uses some sort of mathematical algorithm and comes up with a number, and that number, which we derive from the mathematical algorithm, is placed right here in FCS. When the sender receives this frame, it does the same thing. It uses the same mathematical algorithm, and this number has to match. So if the FCS number does not match, then it sends it to the higher layer like TCP to resend the packets and so forth. But we're not talking about TCP right now. We're just talking about Ethernet, which operates, by the way, at layer 2, which is data link. If you have a chance to read the OSI model, you'll see layer 2 is basically data link, layer 3 is network, and so forth. I will compile a lesson on that, also OSI layers, as time permits. But hope this is clear to you. This is what the IP, not the IP, but the Ethernet frame is. Once again, you have destination MAC, you have source MAC, you have type 2 byte, which basically tells you what type of version is it, IPv4, IPv6, and so forth. Actual data is right here, and this is basically frame check sequence, which uses CRC, cyclic redundancy check, mathematical algorithm to calculate the number, and that number has to match. Both sides will run the mathematical algorithm, and both sides have to see the same number. If it's not, then you've got a problem. But that's all I wanted to say in this particular lecture. Hope you enjoyed it. If you have any questions, feel free to contact me and I'll be happy to reply. And if you like the contents of this, please go ahead and give me a like. Thank you. Till next time.